Hello viewers, you're welcome back to my channel. This is the third lesson on the video series on circle geometry. And in this video lesson, we are going to look at more theorems in circle geometry. In the part 1 of this video, we looked at an introduction to circle geometry and some basic concepts in circle geometry. Then we moved on to look at lesson 2, where we looked at 3 theorems in circle geometry, which include the theorem 1, 2, and 3. And in this video lesson, we are going to look at 3 more theorems, which include theorem 4, 5, and 6. So we'll move on to the 4th theorem in circle geometry. So the 4th theorem, or theorem 4, states that the angle which an arc of a circle subtends. Now, in the first part of this video lesson, we defined what is known as an arc. And we said an arc is an incomplete circumference. So the angle which an arc subtends or produces at the center is twice, that is twice, means 2 times the angle which that same arc will produce at the circumference. Now, what does it simply mean? We have an arc. So from here to here is an arc. So the angle which this arc will produce at this center, now O is the center of the circle. The angle at this center will be 2 times the angle at the circumference. Know that this is the circumference of the circle. Then this point is the center of the circle. So this theorem is very simple and basic. The theorem tells us that provided that is the same arc, this is the same arc, this is the point, and this is the point. This point produces this angle at the circumference and also produces this angle at the center. Provided that arc is the same, the angle at the center will be 2 times of the angle at the circumference. That means that if this is x, at the center is going to be 2 times. That will be 2x. So let's take a look at this one. Let's say we have an angle at the center which is 60 degrees. This theorem tells us that provided the arc is the same, if you look at both of them, an easy way to know is that they both have their feet at the same point, at this point and at this point. So this angle at the center is 2 times of the angle you have on the circumference. So if here is 60, this is going to be 2 times 60, and that will be equals to 120 degrees. Again, theorem 4 tells us that the angle which an arc of a circle subtends or produces or opens at the center is twice the angle that same arc will subtend at the circumference. So in essence, angle at the center is twice the angle at the circumference. So our 5th theorem, or theorem 5, tells us that the angle in a semicircle is at right angle. Now, in this theorem, there is a new term here, which is a semicircle. The word semi just simply means half. Just like we have half time in the game of football, which is 45 minutes, because the game of football is up to 90 minutes. So half time is 45 minutes. So semi just means half of a circle. And how can we have the half of a circle? You can have the half of a circle when you add a diameter. Remember, a diameter is a line that runs from the circumference, passes through the center, and runs to the other edge of the circumference. So on this note, we have a diameter. So a diameter, we simply divide this circle, this entire circle, into 2 equal parts. So we have this part above, we have this part above, and then we have this part below. So the part above is a semicircle, the part below is a semicircle. So we then have something like this. Now, what is this theorem telling us? The theorem is telling us that the angle which a semicircle will produce. So let's take this, and then let's take this. Also, let's take this, and also let's take this. So this theorem is trying to tell us that the angle in a semicircle is a right angle. Again, what's a right angle? A right angle is simply an angle that is equal to 90 degrees. So this angle produced by this semicircle, the angle here is 90 degrees. Similarly, the angle here is 90 degrees. So if we have something like this, we have a line that runs through the center, which is a diameter. This is the center of the circle. And then we have something like this. the angle produced here is equal to 90 degrees. So in essence, when you have a semicircle, the angle that semicircle subtends is a right angle. So in the sixth theorem, we have it that angle in the same segment of a circle are equal. Again, in the first part of this video series, we looked at segment of a circle, and we said that a segment is formed by a chord and an arc. And we know that a chord is a line. So if we have a circle, and we have the center. A chord is a line that does not pass through the center. It's similar to a diameter, but in this case, it does not pass through the center. So this is a chord. So what we have above, this part above is a segment. This part below is also a segment. Just that the bigger part is known as a major segment. And then the smaller part is regarded to as a minor segment. Minor means small, then major means big. So we have a minor and a major. Now, what was this theorem trying to tell us? It's trying to tell us that in the same segment, the angles you have there are what? Equal. Now, how do I know this is segment? We have the center of a circle. I can take a line that passes through the center. So that passes through this point where they meet. So this line that passes through here is a chord. So this line divides the circle into this smaller part here, which is a minor segment, and then this bigger part above, which is the major segment. So now if you look at these angles, they are in the same segment, this angle and then this angle. So in essence, these angles are equal. What does that mean? If here is x, this other side will also be x degree. So if this angle is 60 degree, this angle here will also be 60 degree. So in essence, provided the angles are in the same segment, they are equal. But now you have to take note of something. This angle here is at the center. And remember our fourth theorem where we said angle at the center will be 2 times the angle at the circumference. So if here is 60, here is 60, this will not be 60 even if it is in the same segment. The difference is that this is an angle at the center. So this will be equal to 120 degrees. So similarly, we have this here. If you look at the point where they meet and the point where they meet, if I take a line that passes through it, so this line that goes through it is not going through the center, hence this is a chord. So this line right here, divide the circle into this part below, a major, and then the part above, a minor. So this angle here and this angle here are in the same segment. So if here is 120 degree, similarly, this will also be 120 degree. So we have some practice questions in this video and we are going to take a look at them one after the other. So the first practice question here, and we have the instruction which says in each of the diagram, find the marked angles. So we have this diagram here. Then we have this angle marked here as M. And we have an angle at the circumference which is 70 degrees and an angle at the center which is M. Now, in our fourth theorem, we said angle at the center, this is the center of the circle O, is twice that at the circumference. So remember, angle at the center is twice. Twice simply means 2 times the angle at the circumference. So in this case, we know that the angle at the center right here is M is equal to 2 times. Now the angle at the circumference is 70 degrees. So therefore, the angle M will be equal to 140 degrees. So this is the answer to the first practice question. So in the second practice question, we are meant to look for X, which is the unknown angle in this circle. And how do we approach this question? Now, if you take a close look at this circle, you find out that we have a diameter. And what's a diameter? A diameter is a line or a straight line that runs from one point of the circumference, passes through the center, this is the center of the circle, marked as O, and then runs to the other point on the circumference. Since we have a diameter, And we know that a diameter, we divide this circle into two halves. So we have one half above, and then we have a second half below. So each of these half is what we can rightly call a semicircle. And in one of our theorem, we said that the angle formed by a semicircle is at right angle. So this point and this point, they open up an angle at the circumference, which is this angle here. So the angle here is 90 degrees. So in exam, you'll be given a question like this and you'll be wondering, why is this point absent? Now they expect you to know that the angle subtended on the circumference by a semicircle is at right angle. So in this case, we have a triangle, which I'll rightly draw out. So we have something like this. We have this. This is 58 degree. The angle above is 90 degree. And then we are told to look for x. Now this will take us back to our knowledge on triangle. Now in a triangle, the sum of angles in a triangle is equal to 180 degree. So you ought to know this right now. So the sum of angles in a triangle is equal to 180 degree. So what does that mean? That means that if we add up angle 90, secondly angle 58, thirdly angle x, this should give us 180 degrees. So we have it at 90 degree plus 58 degree plus x is equal to 180 degrees. So 90 plus 58 is 148 plus x is equal to 180. So when we collect like terms, so x will be equal to 180 minus 148. So therefore, x is equal to 32 degrees. So in this question, the value of x, which is your known angle, is 132 degrees rather. So that's 32 degrees. So in the third question, we have this circle. And in this circle, we'll find out that we have an angle at the center, O, which is 3x. But in this case, we are meant to look for the unknown, which is x. Then we have an angle at the circumference, which is 75 degrees. And in one of our theorems, we rightly said that angle at the center is 2 times or twice the angle at the circumference. That's 2 times the angle at the circumference. So now what do we have in this case? We have that the angle at the center is 3x. That's 3x is equal to 2 times. This is the angle here at the circumference, which is 75 degrees. So that's 2 times 75 degrees. So 2 times 75 is equal to 150 degrees. So when we divide both sides by 3, this should give us 50 degrees. So the answer to this question, x, is 50 degrees. But the answer to this angle at the center should be 3 times x, which is 50. And that will give us 150 degrees. So in the fourth question, we have this circle. And if you look at this circle, we have an angle at the center, which is B, which we are going to look for. Then we have an angle at the circumference, which is A. Now, to answer this question, we have to bring in multiple theorems. And what's the first theorem? In the first theorem, we know that angle in the same segment of a circle are equal. So if I pass a chord through this part above is a segment, then this part below is also a segment. So in this case, angle in the same segment at the circumference are equal. So if this is 65, automatically this other angle A will also be 65. So therefore A is equal to 65 degrees. The singular reason is that angle in the same segment are equal. Angle in the same segment are equal. So we'll head on to look at B. Now in B, we'll find out that angle B is an angle at the center. And recall that angle at the center, that is B, will be 2 times the angle at the circumference, which is 65 degrees. So the answer is simple. Angle at the center is twice the angle at the circumference. So now when we multiply 2 times 65, that will give us 130. So therefore B will be equal to 2 times 65, and that's 130 degrees. So the answer to this question is 130 degrees. So viewers, I hope you enjoyed this video lesson and you learned something from this video lesson. Do it to give this video a thumbs up, and also do it to share this video lesson to your friends. If you have any question or suggestion, do it to leave them in the comment section just beneath this video lesson. And for those who haven't subscribed, do it to click on the subscribe button so that you get to see my next video. Do have a wonderful time.